This is Mr. Martin. These are the video notes for section 3.6, types of triangles. So most of this information I'm sure you've learned before, so hopefully it's just a refresher for you, and maybe there's a few bits of information that'll be new for you. And then of course we'll be applying it to do proofs as well, and there'll be some algebraic geometry in there as well. So 5 bullet points here for you. Make sure you know the 3 types of triangles classified by the lengths of their sides. The 4 types of triangles classified by the measures of their angles. And then you're going to need to know the definitions and their converses. Definitions and converses in if-then form for all the types of triangles. Again, when we do our 2-column proofs, I want almost everything in conditional form, so if-then form. We're going to have an isosceles triangle that's going to have some parts, and we're going to have a right triangle that's going to have some parts that you may know already. So this should be just review. Okay, so I've got some stuff filled in here already. Classifying triangles by their sides, we're going to draw a picture. The definitions I already have in here. When you make your theorem sheets and put these in, you may want to put the converses. If you want to just double check with me in class that your converses are correct, I would encourage you to do that. Again, they're going to be in if-then form. We're going to label our parts, etc. So if you want to pause the video now and then copy the information that I have so far, and then restart the video when you're finished, that would be a good idea to do that now. Okay, so our first triangle is the scalene triangle. So let's just sketch in a little picture here. And if I want to show that the triangle is scalene, I'm just going to give each side a different tick mark. So since they have different tick marks, we know that the sides are not the same. That's pretty much it for a scalene triangle. For an isosceles triangle, and this is going to be one of the most important triangles for us because we're going to be using them so often, we've got a triangle with at least, and this is key here because there are some textbooks that define this as at most 2 or only 2. So our book is at least, which would mean that if it has more than 2, we could also classify it as isosceles, even though it might be able to be classified as something else. So I'm going to label this ABC. If a triangle is isosceles, then at least 2 sides are congruent. An isosceles triangle has a vertex angle. So angle A is the vertex angle. And it has 2 base angles. So angle B and angle C are the base angles. And it has 2 legs. So those are the 2 congruent sides. So AB and AC are the legs. Okay, make sure you know what all those parts are. Moving on to equilateral triangle. Again, if we're going to make a sketch and show that it's equilateral, my picture's a little bit off, but if we just put these tick marks here, then we know that it was intended to be equilateral. All right, so there's our 3 triangles classified by their sides. Some other useful forms of these definitions. If a triangle is isosceles, then its legs are congruent. If a triangle is isosceles, then its base angles are congruent. So these are going to be important. Use when you already know triangle is isosceles. All right, and I'm going to give you these 2 here, but really we're not going to use the second one yet. We'll use it in another section, but I'm going to give it to you here for a preview of things to come. We're going to do an example in the other part of the notes today that we're just going to use this first converse, okay? But these are used to prove, then it is isosceles, so we're going to use these to prove. And again, the second one is a preview of things to come. We're not going to use it today. All right, so let's move on to classifying triangles by their angles. Again, I've got some information pre-filled out here. Um, so if you want to pause the video, let's see if I can fit this all in here. If you want to go ahead and pause the video and fill in your chart, that would be a good idea to do that now, and then when you restart, we'll draw some pictures and add in some other information. All right, so our first triangle is an acute triangle. So incidentally, if it's acute, all its angles are acute. So for example, this could be 60 degrees, this could be 80 degrees, this could be 40 degrees. Okay, all the angles are acute. This one happens to be a scalene acute. If all the angles are different, all the sides are going to be congruent. But all its angles are acute. Now with an obtuse triangle, and you may remember this from when you studied this before, if a triangle is obtuse, then one angle is obtuse. And if you think you know why it has to be only one, next time I see you in class, let me know what you think about that. So an obtuse triangle, let's make this angle up here 100, so there's our one obtuse angle. And then these two over here would be acute. Maybe that's 50, maybe that's 30, just to give an example. All right, moving on to the right triangle. So I'm going to sketch in my triangle. And we'll call this triangle ABC because we're going to need to refer back to some of the pieces. If a triangle is right, then one angle is right. And we call the longest side the hypotenuse, and it's opposite the right angle. So here's my right angle. If I go opposite that in the triangle, that would be my hypotenuse. So AC is the hypotenuse. And the two shorter sides are called the legs. So in this case, I've got AB and BC are the legs. And right triangles also are going to be very important for us. Moving on to equiangular triangles. So now I'm going to make all the angles congruent. If a triangle is equiangular, then all the angles are congruent. And an equiangular triangle is also equilateral. So really it's just two names for the same type of triangle. One we're just referring to its congruent angles. The other we're referring to its congruent sides. Okay, so moving on to our first example. And again, this is where I was talking about the fact that I gave you two ways to prove a triangle is isosceles, but in this case I'm going to use, to prove triangle is isosceles, get two sides of the triangle congruent. Okay, so if I'm looking at this triangle in the center here, this is the one I want to prove is isosceles, triangle KPM, then I've got to get KP congruent to MP. So that's what we're going to work on in this proof. So like we normally do with the proofs, if you want to pause the video and see if you can figure it out, I'm going to pause my video and I'm going to write out the proof so that when you restart the video, you'll have the completed proof. And then I'll go through and point out some important things through the proof. But make sure you leave a little bit of room because we're going to do 9 steps, so 6 steps after the given, and room might get a little tight on your worksheet. So go ahead and pause if you'd like to, and restart it when you've completed the proof. All right, so here's our completed proof. So if you take a look at the picture, notice I marked with tick marks the things that were given, the parts that were congruent. And once we have that down, I know that these large angles in the corners, JKM and OMK, are going to be congruent because congruent angles are added to congruent angles, then the sums are congruent. And I know that KM is congruent to MK by the reflexive property. Notice that I have these switched around because this triangle on the, I'll just highlight the one triangle here. This is one of the triangles. And then I'm going to try and prove that congruent to the other triangle. So these two triangles are flipped. So it's KM on the triangle on the left. It would correspond to MK on the triangle on the right. And then once I have that reflexive property, I have enough to say the triangles are congruent by angle side angle. And then JM is going to be congruent to OK by CPCTC. And then since I was given these small angles up at the top were congruent, I could subtract those from the corresponding parts in step 7 to get PK and PM. And these are the two legs of the isosceles triangle. So once I get those congruent by subtraction, then I know that triangle KPM is isosceles. If at least two sides of a triangle are congruent, then it is isosceles. So go ahead and make any corrections, pause the video, write down any questions you have. Make sure you ask me the next time you see me in class. It's important to follow up. And then you're going to want to go ahead and pause the video and work on the second problem. And this one is kind of a review problem, so it doesn't really use any of the new concepts, but it's a good problem for beyond CPCTC. And we'll see you in class. I'll say a few things after the next problem, but go ahead and pause the video now. All right, so here's the solution to the second example problem in the notes. If you notice, I need to prove some overlapping triangles congruent, so I redrew those separately at the top to make it a lot easier to see what I've got going on. So these angles here were given, and these sides here were given. So once I split it apart, it was really easy to see that I had angle F in both the triangles, so I could use that to prove the triangles by angle side angle, which it looks like I left out of my proof here. So I'm going to go ahead and stick that in at, make that 3.5. So I've got triangle, what do I have there? FDB is congruent to triangle FCA 3.5. That's going to be by angle side angle. And let's see, I've got steps 1, 2, and 3, which are the only ones I could have since they're the only ones in front of that. Okay, so 3.5, that's going to fit in right over there. Then I've got FA and FB are corresponding parts, and then I'm just going to subtract these from those to get AD is congruent to BC. So as always, write down any questions that you have. Make sure you ask me in class, and we'll see you next time.